Welcome to Chapter 3, yay! So Chapter 3 is all about solving equations. And so some of you might already have done some solving equations here and there. Will you please make sure that your name is on your notes here? These things, this is like a big packet, right? I don't make a lot of extra copies, so I need you to keep track of it. So that I'm not going to make more. All right, if you lose it, you're out of luck. Okay. So we are going to start solving equations, and just like I always like to do, I really like visual examples here. So I don't know if any of you have ever seen these before. You probably haven't. These are algebra tiles. So in this bag here, these are algebra tiles. And this, you're going to see these algebra tiles come out quite often because I love using them. These little sticks, these represent an X, all right? An unknown, all right? A variable we're trying to solve for, okay? And so here, this is 1x. What does this represent? 2 x's. And what does this represent? 3 x's. Good. Okay, and so I have those x's, and then I also have these little units here. What do you suppose these represent? A 1. They're little single units. That's a 1, a positive 1, in fact. And here's another one. So what does this represent? 2. Very good. And what does this represent? 4. Super. Okay. So we are starting to solve equations, and it turns out the first day here is going to be super easy, but I just want to sort of give you an idea of what's happening. So when we're solving equations, I actually like to think about it as balancing equations, okay? So what did I just draw here?
Triangle over a scale.
It's a teeter-totter. Yeah. A teeter-totter, okay? The idea is that we want this to balance, so the left side and the right side should be equal, okay? So if I have, and the way we think about this is this little, this is called the fulcrum, the thing in the middle, the fulcrum, the balancing point. We want these two sides to be equal to one another. They should be exactly level, okay? And so what we can do is we can set up little equations to sort of solve for our unknown, which turns out most of the time to be pretty easy here. Well, so here's my equation. What is x worth? Is the left side equal to the right side? Oh yeah, is it balanced? So x is equal to 4. Yeah, that's exactly right. X is equal to 4. Okay, so then what if I do this? I say, hey, now here's my my left side now, and here's my right side. Okay, but I need these two things to be equal. So I just want to know the value of x. What does x have? What must x be so that these two things balance? 2. How'd you figure 2? Because it's 2. It's too easy. Yeah. No, what you got?
Because there's 4 one tiles, and then there's 2 tiles on one side.
Okay.
It's like 4 minus 2.
It's like 4 minus 2. So my daughter, I don't know, my younger daughter, some of you know my younger daughter, I did this with her this summer. This is what we do in my house during the summer. We do math. Anyway, so she's like getting things nice and arranged here. So she said, well, I only want to know the value of this, so I want to get rid of the extra stuff, all right? So if I get rid of the extra stuff here, I want to get rid of 2 here. But if I take these off, is my scale going to be balanced? No. What if I take them off of both sides? Can I do that? Yeah? And if I remove both of these, is my scale still going to be balanced? Yeah. Okay, so as long as I remove the ones from both sides, and then, whoops, daisy, and now we can see that what's the value of x? 2. X is equal to 2 units. Okay. And so our equations can get super complicated if we want to. And that's what we're going to be working on this whole unit, is what happens when our equations get more complicated. So what if I have here let's do this. Let's say, hey, here I have 2x's is equal to 6, and we're balanced. All right? Now, the 2x is equal to 6, and we're balanced. So I want to know, what is just one of those x's worth? 3. How'd you figure that? Okay, because, we want to split them into 2 equal groups. We have 2 equal things here, all right? And so I want to arrange these also into 2 equal groups, all right? So that they're the same, right? That's division, splitting things into 2 equal groups. And so now we can see, what is 1x worth? 3 units. And here's the other x is also worth 3 units. They have to equal the same thing. Does that kind of make sense to you? All right. And then we can get even more complicated. Maybe we have an equation like this, where we're saying, oh, that's kind of a boring, I think. Let's do that. All right, so now this equation, I have 2 x's and 2 units, is balanced with 10. So how are we going to, again, figure out what is the value of just a single x there? Take off the 2. Okay, so we've got a 2 here. I'd like to get rid of it, but again, if I lift off the left-hand side, what happens to my scale? All right, one side, one side, all right. So if I remove it from the left, what else do I have to do? Remove it from the right. We've got to remove the same amount, all right, and they'll stay balanced. Does that make sense to you? Keeping things balanced here. Okay, so we remove things from both sides, and now, how do we figure out the value of just one of these x's? Split it into 2 groups. 2 equal groups, all right? So I'm going to split them apart, which means I had 8 here, so what should each group get? 4, like that. So now 1x is equal to 4, and here 1x is also equal to 4. Does that make sense to you? Ladies and gentlemen, you just solved 2-step equations that we're not doing until next week. All right? Who knew, right? So math is very, very visual, and I never learned it that way, but I kind of love it. So I want you to keep that in mind, and I'm going to keep busting out these algebra tiles every day to kind of show you what we're doing. And so we are going to do a bunch of practice problems here today. I want you to keep in mind the idea of keeping that teeter-totter balanced, okay? You got to keep it balanced. And so keep that in mind. That equal sign is our little fulcrum point. So today, here we go. We are going to be able to solve equations using addition, subtraction, multiplication, and division. And how are we going to do that? First, we want to figure out where is the variable. Ladies and gentlemen, what is a variable? It's the letter. It's the letter in the equation. It's the unknown. It's the thing we're trying to figure out, okay? We want to determine the operation tied to the variable. What are they talking about when they say the word operation? The operation talks about multiplication, addition, it's the add, subtract, multiply, or divide. So what operation is tied to the variable? What operation is connected to the variable? I'll talk a lot about that. And then we're going to use the inverse operation. What do you suppose inverse means? Opposite. Sort of the opposite. What's the opposite of addition? Subtraction. What's the opposite of multiplication? Division. Okay? All right. And then use the inverse operation on both sides of the equal sign. Why do we have to do it on both sides? So it stays even, so it stays balanced. Again, we're balancing that little teeter-totter. All right, and then, hey, you know what? You know what the coolest part of math is, and this is why I love math so much? You can check your answer. Every single time, ladies and gentlemen, you can guarantee yourself 100% on your next test if you check your answer and make sure it works. And it's not hard, especially since you guys are allowed calculators. It's super easy to do. Okay? So we want to practice doing that a little bit as well. Okay, so inverse operations can be used to solve equations. Addition, if I have an addition connection, what's the inverse operation? Subtraction. All right. If I have multiplication, what's the inverse operation? Division, yes. Yep. Multiplication and division are inverses. All right, so here we go. We're going to play around with this a little bit. Okay, I have my little equation right here. And again, if you think about what I just did, here I have an x and 7 little units on one side. 1, 2, 3, 4, 5, 6, 7. There we go. There we go. There's my x plus 7 on one side of my equals sign. Oh, you can't quite see all of it, but there we go. And then that's going to be equal to, ooh, interesting. On the other side, right, what does the red side mean? -1, yeah. Hey, look at that. Okay, so again, my goal is to figure out, hey, what is the value of x? Ooh, what are we going to have to do? Yeah, all right. So right now, the operation connected with the x is a plus, a +7. And what is the inverse of +7? -7. So what we're going to do is we're going to subtract 7 from both sides. All right. What is a +7 and a -7? 0. Hey, that goes away. That is a 0 property. All right, and so when those 7s go away, what's left on the left side here? An x is all by itself, which is what we want. You got to bring down your equal sign. And then on the right-hand side, I got a bunch of negatives. Who wins here? They combine. Yeah, these are just all negatives. How many negatives do we have here? -8. Ladies and gentlemen, there's your first equation. If you know how to do this, you can go ahead. Just make sure that you're showing your work, okay? So if you know how to do this, you just keep on keeping on. All right, great. I'm going to show you how to check a little bit later on more complicated problems. We'll do a couple here in a few minutes. All right, here's my variable m. It's got a -11 with it, and I want to isolate the m. So what do I need to get rid of? How can I get that m all by itself? Yeah, we want to get rid of this -11, so we're going to do the opposite, the inverse operation. We're going to add 11. Can I just do it here on the left side of the equals? Or do I need to do it both sides? I got to keep it balanced. Keep that thing balanced. So what is a -11 and +11? 0. So cross that out. It makes a 0, nothing, and I get my m. Bring down my equal sign, and what's on the right-hand side? A 2. Very good. Positives win by 2, and that is our answer. Beautiful. Number 3. What's different about number 3? Yeah, it's got I would say the variable, the letter is on the right-hand side, but that's okay. It's okay. We just want to get that h all by itself. What do I need to get rid of? The 14. What is the 14 right now? Is it a +14 or a -14? Yeah, it's got a little invisible positive sign there, right to the left. Right to the left. Beautiful. On the left side of that, okay. So how do I get rid of a +14? We're going to do a subtract 14 or -14. Now here I put it on the right-hand side. Where else do I need it? On the left-hand side as well. Got to do both sides of our equals. What is +14 and -14? 0. All right. So my h and my equal sign comes straight down. And we have a 9 and a -14. Who wins? Negatives win. By how many? -5, very good. All right. Let's look at number 4. We want the W all by itself. What should we get rid of? It's a -15. How are we going to get rid of that -15? Add 15, yeah. +15 on both sides. Left side and right side. -15 and +15 makes a 0. And we're left with just that W. And my equal sign comes straight down. And we have 14 plus 15. What is 14 plus 15? 29. All right. How do you feel? Good? Give me a thumb. How does that feel? Are we good with this section? Yeah? Okay. So that was connections with addition and subtraction. All right, so it's really just doing the opposite, and the goal is really always is to isolate the variable. Isolate, get it alone. Get rid of the other junk with it. All right, clean it up. That's our goal here. So now we want to move on to set 2 here. We want to solve each equation. Here, our operation that's connecting is a multiply or divide. So when I look at number 7 here, I want to read it out loud. This is for A. What operation is in between those two? Multiplication, yeah. It's invisible, so maybe you want to write it in. This really means 4 times A. Well, how do we break multiplication? What's the inverse of multiply? Divide. So we're going to divide both sides. We're going to use a little division bar because it's easier. Because we want to get rid of the 4. We're going to divide both sides by 4. What is 4 over 4? 1. How many times does 4 go into itself? 1 time. So that is a 1A. Do I need to write the 1? No. Is it a 0? No. And I want you to make sure you understand that. 1A is the same as just a plain old A. Okay? All right, I'm going to bring down my equal sign. What is -24 divided by 4? 6 or -6? -6. If there's one negative sign, it's negative. All right, odd number, negatives, negative result. Okay, number 8. Our equation's flipped over, but that's okay. We have -7. What's the operation? -7p. What's operation in between those? Multiplication. Very good. So we want to get p by itself. How do I get rid of that -7? Divide. What do I divide by? Do I divide by 7 or -7? -7. We want to get rid of the whole number. So take that negative along for the ride. What is -7 divided by -7? 1. Every single time, ladies and gentlemen, we want to get a 1p in this case. -7 divided by -7 is +1. That's our goal. We want to get just a single p. All right, what is -56 divided by -7? 8. +8. Very good. We have an even number of negative signs, so it's going to give us a positive result. All right, and that's it. We're done. All right. Okay. It's huge. It's a big. This is the meat and potatoes right here. This is everything. Ooh, interesting. Number 9 and 10. Number 9 and 10. Number 9. Let's read this out loud. In divided by 5. Love that you said it that way. In divided by 5. Ladies and gentlemen, how are we going to get rid of the 5? Multiply by 5. Yeah. In divided by 5, I've got to do the inverse operation. So we're going to multiply both sides by 5. And I need you to squeeze it in just like that. Times by 5. Times by 5 and divide by 5. That's like 5 over 5. What is 5 over 5? 1. So we get that 1 in again is equal to, what's on the right-hand side now? 45. Very good. All right. And we're good to go. 1 in. 1 in is really the exact same thing as plain old in. All right? They are exactly the same. All right, number 10 says 2 is equal to R divided by negative 8. So how do we get R by itself? Times by negative 8. So write it in there, smush it in, times by negative 8 on both sides. So we have a times by negative 8 and divide by negative 8 that cancel each other out, leaving the R, or 1R if you want. What do we get on the right, left-hand side, rather? Negative 16. Negative 8 times 2 is negative 16. Beautiful. All right, 11 is really interesting. I feel like I'm missing something. Do you feel that something is missing here? Makes it a little harder. What should we do here on number 11? Add a 1. Put in a 1. Negative 1k is equal to 7. And so when you have that, you want to put in the 1 because that's going to be really helpful there. There's always a little invisible 1 if there's a number missing. All right? So now this says negative 1. What's the operation? Multiplied. Negative 1 times k. So how do we get rid of that negative 1? Divide. The inverse operation, we're going to divide each side by negative 1. What is negative 1 divided by negative 1? 1. So that cancels out to a 1k, or a plain old k. And 7 divided by negative 1 is? Negative 7. Very good. All right, you have questions so far, or are you good to go? You're good? Okay, we're going to do, let's go down here and do some of these bigger ones. Let's look at 19 and 21 here. All right, so this is mixed practice. We want to solve each equation. And because these are bigger numbers, I'm going to show you how to check on these, so we're good. Number 19 here. We want the W all by itself. What do we need to get rid of? The negative 47. How are we going to get rid of the negative 47? Add 47 to both sides. Negative 47 plus 47 is 0. It's gone, out of here. So I get a W is equal to, who's going to win here? Positives by how many? 37. Beautiful. So here's what we think our answer is. Now, how do we check? So to check, we plug it back in. So what we're going to do to check is we're going to take this number and we're going to pop it right in place of what it says it's equal to. It's a replacement. So we're going to go back to the original equation and pop it in. So I have that original negative 47 plus, what am I plugging in place of the W? A 37. And we want to know, does it equal our negative 10? So I used a little question mark. All I need to do is put this in my calculator, put in this left-hand side in my calculator, or maybe you're good enough, but we're verifying, so I want to make sure I don't make a mistake here. So in my calculator, I am going to type in negative 47 plus 37, and it gives me negative 10. So this is negative 10 equals that right-hand side. So we were balanced. All right? Our equation is balanced. So to check, all you have to do is take it back and plug it into the original. Okay? I always plug it into the original because it has no mistakes. Let's look at number 21 here. Negative 48 equals, read this side to me. Negative 16 times A. Times A. So how do we get A by itself? Divide by negative 16 on both sides. Negative 16 divided by negative 16 is
3.
1. 1A. Good. Negative 48 divided by negative 16 is 3. There it is. Okay. So we think that that's correct. How do we check it? Plug it in. Plug it in. Plug it in. We're going to take that 3 and turn it right around and plug it right back in to our equation. So I'm going to rewrite that. Negative 48. Does it equal negative 16 times? Now, I'm going to plug it in. I'm always going to use parentheses. That's sort of what I told you to do before, I think. When I plug in, you want to use parentheses. So I'm going to put it in like that, negative 16 parentheses 3. And I want to do this operation in my calculator here. Let's see what we got. Negative 16 parentheses 3. And I get, yay, negative 48 is equal to negative 48. So we balanced that equation perfectly. All right. Questions so far? Last one. Number 24. Number 24. Read this out loud to me. 6 times n. Very good. 6 times n equals 0. How do we get n by itself? Divide by 6. Very good. 6 divided by 6 is 1 n. And what is 0 divided by 6? 0. Is 0 a number? It sure is. Can it be an answer? It sure can. All right. Very good. Do you have questions for me? Okay. All right. Fantastic, ladies and gentlemen.